Hello, everyone. My name is Hadiza Yusuf. I am a master's student of Engineering and Special Intelligence at Carnegie Mellon University, Africa. And I'll be presenting a project proposal titled DTMF Demodulation, a brief investigation of machine learning for digital signal processing. The outline of my presentation as follows. I'll talk about the background of DTMF, its application, detection, our proposed experimental setup, our proposed performance evaluation, then I'll conclude. Dual tone multi-frequency, commonly known as DTMF signaling, is a widely used technique with diverse application in various fields. It was first developed by Bell's Lab for the purpose of automatic long-distance call to replace conventional telephone call back in the 1960s. It was designed to send control signals within a voice band. Now, each tone is used in identifying a push button on its DTMF keypad. A DTMF keypad is what we can see on the left side of the screen. It has 16 keys, with each key formed by combining two sine wave tones, one of which is a low frequency sine wave and the other a high frequency sine wave. As you can see, the rows having low frequencies and the column having high frequencies in and these frequencies are combined to form unique keys, which are not being confused with other keys. So the significance of DTMF on telephones has decayed over time due to separate control channels in cellular transmission, but their association with the keypad has kept them alive for many applications today, which we're going to see. Some of the applications of DTMF are in smart home automation, where DTMF-based technology is used to control various devices such as light, heating, ventilation, air conditioning, the movement of gates and doors, and even in security systems. Another application of DTMF is in mobile controlled robots. So the DTMF is keys on a telephone or a mobile phone is keys on a mobile phone is mapped to different movements that a robot can make or operations that it can do. And then when a key is pressed, the sensor on the robot is able to detect what instruction is being given to the robot. Or DTMF can also be used for interactive voice response in banks for customers to access their account information or to make transactions. It can also be used in emergency services to identify the location of a caller and dispatch emergency responders. DTMF can also be used in military communication system to transmit encoded messages and to control remote equipment. It has many other applications in industries. So over time, classical algorithms have been used to detect DTMF. One of which is commonly used is known as the Guazel algorithm. The Guazel algorithm is a mathematical algorithm used to find the presence of a particular frequency in a given signal. To understand this in simple terms, imagine you are in a concert and you want to know if a guitarist played a particular note in a song. You do that by focusing your attention on that particular note and counting the number of times it played, that note is being played in the song. So in a similar way, Guatel algorithm works by focusing on a particular frequency in a signal and also counting the number of times that frequency appears in the signal. And if it's able to detect a chunk of that frequency, then it can conclude that that frequency is within the signal. So compared to other classical algorithms, Guazel has been found to be very fast, but even faster than fast Fourier transform. But it is not robust to distortion or noise. And we know that in real situations, audios or signals, when signals are being transmitted, we cannot avoid distortions or noise. And this is the reason for this is the reason for wanting to explore the use of machine learning models in detecting DTMF. So our proposed experimental setup is we will be using PC as our modulator, and an Arduino NanoSense, which has a microphone to receive audio signals, and it would be our demodulator. So the PC will be used to generate two frequency signals simultaneously for a brief interval of time, and each of such transmission is one symbol. So at every interval of time, 4 bits will be sent by the sender, which is our PC. So the process of mapping bits to symbol when encoding is called modulation. For example, we have vertical frequencies and horizontal frequencies here. So this one vertical frequency and one horizontal frequency forms a symbol, and converting that symbol to bits is known as modulation. Then the modulation is what the decoder does to determine which symbol was sent. So we will generate our training data on the PC synthetically. At first, we would use perfect symbols without distortion. Then later on, when we're able to get the system working, we can now start distorting the symbols by adding different noise to them. So another way we hope to get data sets that includes distortion is to capture our training sequence with an Arduino, where the signals are being generated on the PC, and then we play them, and the Arduino receives them as audio signals. So with distortion from the environment. So this would be done after two systems are being synchronized. So after that, we will run an ML inference, specifically TensorFlow Lite, and then this model will classify received signals and predict which of the 16 classes corresponding to the 4 bits was sent. So to evaluate our model, we are going to be answering these questions. We'll look at how small of an ML model can be used to get a reasonable performance, and then we'll check how fast we can send bits from the PC to the Arduino using DTMF. And then we'll also look at if our synthetically generated training sets perform as well as the training sets we captured with the PC and Arduino combination. That's the training set that has distortions in it. And then finally, we would also compare a classical model with our model, with our machine learning model, and see which one performs better and which one also shows more robustness in the presence of noise like speech and music. So in conclusion, we hope that this investigation will provide valuable insights into the potential use of TinyML for DTMF demodulation, as we have seen that it is DTMF is important in several applications. So we look forward to sharing our findings. Thank you.